that is the roots of the equation. These are our roots, that is minus a and then 3 over 5a. In the next example, we are going to be making use of the roots to get our expression. So we will take the next example, which is example 3. Example number 3. Find the quadratic equation whose roots are x is equal to minus 2 or x is equal to 7. From the other previous examples, we actually got our roots from the quadratic equation. But now we want to get our quadratic equation from our roots. The previous ones will be getting our roots from the quadratic equation. But here we are being given the roots. We are expected to get our quadratic equation. From this expression, we can easily say that x minus x plus 2 is equal to 0, or x minus 7 equals to 0. If this plus 7, when it is crossing, it will become minus. When this minus is crossing, it will become plus. So we are now having something like this: x plus 2, x minus 7 equals 0. Now we multiply. That will be x. We are using this x to multiply everything in this bracket. It will now be x squared. X times x is x squared. Minus x times 7. X times minus 7 is minus 7x. Now we are having plus again. Plus x, 2 times x. That's what? 2x. Now to check this sign, that will be plus 2 times minus 7. That's minus 14. Minus 14 equals 0. Can you see something? We are having this. That usually after we've checked for the products and then we now check the sum, that will give us the multiples of the first and then last time. So we are not having this. It's just like we are going from the back, from the bottom to the top. So we will now be having x squared. If we should add this, that will be minus 7 plus 2. Minus 7x plus 2x will give us minus 5x. Minus 14 plus 0. This is what we are looking for. Linear and quadratic graph. Now, we are going to be solving quadratic equations using graph to solve quadratic equation. But first and foremost, we will be doing revision of what we've done in our junior secondary school. That means we will be starting with the linear graph. The linear function of x is one that contains the terms in x of power 1 only. That is, the power of x is just 1. We don't have anything that is greater than 1. That is, you don't have anything like x squared. What you just have is either x or 5x. That is, we don't have anything that has any value that the power of x, we have the power of x is greater than 1. The linear graph is always a straight line. That is never a curve, it's always straight, which simply means straight line in this context. When plotting the Cartesian graph of a linear graph, it is advisable to plot 3 points, which line is a straight line, in order to have more accurate plotting of the graph. That is, when you are plotting your graph, it is important that you have 3 points. Let's say this is our graph. This is our y-axis, and then this is our x-axis. It is important, and this is our origin. It's important that our 3 points are on the straight line. you can now have a point like this and a point like this. But it's important that at least 3 points are on a straight line. We'll be taking an example now. Given that y is equal to 5 minus 3x, copy and complete the table. Y is equal to 5 minus 3x. And we are meant to copy and complete this table. These are x and y. Minus 3, 0, and then plus 3. Now, for us to get the value of y, we are being given that our x is equal to minus 3. That means y is equal to 5 minus 3. Our x is, we'll now substitute minus 3 for x. That will be minus 3. Minus times minus will give us plus, and 3 times 3 will give us 9. So we'll now be having y is equal to what? 5 plus minus times minus will give us plus. Plus 3 times 3, that's 9, which is equal to 14. That means our y is equal to 14. Now when x is equal to 0, this is when x is equal to minus 3. When x is equal to 0, we are having y is equal to 5 minus 3 into bracket 0. 3 times 0 is 0. So what we are just having is y is equal to 5. Then when x is equal to plus 3, when x is equal to plus 3, then our y from this equation is equal to 5 minus 3 into bracket 3. 3 times 3 is 9. That's 5 minus 9, which is equal to, therefore, y is equal to what? That's minus 4. So this, we'll put minus 4 here. When x is equal to 0, y is equal to 5. And let's draw the graph of the function 5 minus 3x for the values of x from minus 3. That means we are going to create a table like this, but what's the difference is just that here we are having from minus 3 this our x, this our y, this minus 3. Mind you, we are starting from minus 3, then we have minus 2, then we have minus 1, then we have 0, then we have 1, then we have 2, then we have 3. Now, we've already calculated for minus 3 as 14. We've calculated for 0 as 5. And for plus 3 as minus 4. So what we are now left with to get the values of y that we are left with is that of minus 2, minus 1, 1, and 2. So we'll now use from this equation, we just slot in the values of x, that is, we'll substitute the values of x, the various values of x into this equation. So what we are going to be having here is, for when x is equal to minus 2, we'll be having y is equal to what? That's 5 minus 3 into bracket minus 2, which is equal to what? 5 plus what? That's plus, minus times minus will give us plus, 3 times 2 will give us 6. This is equal to 11. So we'll put 11 here. When x is equal to minus 1, y is equal to what? 5 minus 3 into bracket minus 1, which is equal to what? 5 minus times minus will give us plus. 3 times 1 will give us minus 3 times minus 1 will give us 3. That is minus times minus will give us plus. 3 times 1 will give us 3. And that's what? That's 8. So put 8 here. We calculated for 0 from here. Now we'll now go to 1 when x is equals to 1. Our y is equals to what? That will be our y is equals to 5 minus 3 into bracket 1, which is equals to what? 5 minus 3, which is equals to 2. So here our y is 2.